Dear students, good morning to all of you. Once again, I welcome all of you to a session on Sharpe Index Model. We have seen earlier individual stock performance. We have seen the assessing the risk of an individual stock by measuring the standard deviation and the beta. Standard deviation measures the total risk. Beta measures the systematic risk. Then we moved on to calculate the relationship between risk and return by using CAPM model. That is the CML and SML, capital market line and securities market line. Capital market line shows the relationship between risk and return of an efficient portfolio. Securities market line shows the relationship between of an individual stock by using the beta. The CML is based on the standard deviation. And then we moved on to compute the correlation, coefficient of variation, and then calculation of portfolio risk. Then we come to the portfolio. Portfolio risk we have calculated for 2-stock portfolio, 3-stock portfolio, and 4-stock portfolio by using Markowitz model. Then we have seen the major limitation of the Markowitz model is when the portfolio has more than 4 stocks. When the portfolio has more than 4 stocks, it is very, very difficult to determine the risk of a portfolio. This is what we have seen so far. Now we are coming to the last part of our discussion, last part of the course. The major objective of this particular course is to construct the optimal portfolio. How a portfolio manager, how an investor can construct an optimal portfolio. Optimal portfolio, as we have seen earlier, for a given level of risk, the return is maximum. For a given level of return, the risk is minimum. That's what we have seen, optimal portfolio, or we have seen efficient portfolio. We have seen that. So today we are looking at how a portfolio manager, how an investor can construct an optimal portfolio by looking at the risk of various stocks, by looking at the systematic risk of a various stock, that is the beta, and then by looking at the unsystematic risk of a particular stock. The total risk, as we have seen earlier, it's a combination of both systematic risk and unsystematic risk. So systematic risk is a market risk, which no company can have a control over it. No company can eliminate the market risk that we have seen, which is the combination of interest rate risk, purchasing power risk, and market risk that we have seen. And then we have seen the unsystematic risk, which is controllable by the company. It is a company-specific risk. It's what we have seen, leverage risk and business risk. Unsystematic risk is a combination of leverage risk and business risk, which the company can have a control over it. So by having an individual stock return, systematic risk and unsystematic risk, how a portfolio manager or how an investor can construct an optimal portfolio. So that is the major outcome of this particular course. So we are in the last part of the particular course. So the objective of this particular course is to construct an optimal portfolio by having all these constraints. So the constraints are return, systematic risk and unsystematic risk, and then by looking at the market variance, or we have a market risk, and then by looking at the risk-free rate of return. That's what we call it, treasury bills return. Return on treasury bills is called risk-free rate of return that we have seen. So by looking at all these constraints, a portfolio manager or an investor has to construct an optimal portfolio. So that is the discussion for today. Here, kindly, please take the calculator, because a lot of calculation is there. Please take a notebook and pen. Kindly write the steps involved in Sharpe Index Model. So kindly put a heading, Sharpe Index Model, construction of an optimal construction of an optimal portfolio. By using Sharpe Index Model. By using Sharpe Index Model. SHARPE, Sharpe, William Sharpe. So William Sharpe, we have seen in CAPM. CAPM is given by William Sharpe. For the contribution of CAPM, he could not get Nobel Prize. We have seen because CAPM has built based on certain assumptions which are not realistic today. At that time, in 1956, when he has built a CAPM in 1960s, it was true. There are all the assumptions were true. But today, most of the assumptions are not realistic. So based on which he could not get Nobel Prize, and then he went on having a research on kind of the optimal portfolio construction, and then he has developed this model. We call it Sharpe Index Model, for which he got Nobel Prize in 1990. So it's a Nobel Prize paper, Nobel Prize research paper. Kindly take the notebook, kindly note down the construction of an optimal portfolio using Sharpe Index Model. Now, what constraints are given? One, we will be given market variance, we will be given Sensex variance, or we will be given Nifty variance, that is called the market variance, or it's called market standard deviation. We will be given risk-free rate of return, will be given. There's a treasury bill return will be given. Then we will be given a set of stocks, say 7 stocks or 8 stocks or 5 stocks will be given. As I was describing you earlier, mutual fund has got more than 10 stocks. Any mutual fund, if you take, mutual fund has got 10 stocks. So you cannot construct a mutual fund without having 10 stocks in their portfolio. So as I was describing earlier, every mutual fund is a portfolio. Every mutual fund is a portfolio. So every mutual fund manager is known as fund manager, or we call them as portfolio manager. So in a mutual fund, you have a 10 stocks. So from the 10 stocks, how we can construct an optimal portfolio, or every mutual fund is called an optimal portfolio. Every mutual fund is called an optimal portfolio because a fund manager or portfolio manager takes into consider this particular model, the Sharpe Index Model, for constructing an optimal portfolio. So that we need to keep in mind. So every mutual fund is a portfolio. Every mutual fund is known as an optimal portfolio. So he takes, we have about 9,000 plus companies. So from this 9,000 plus companies, he is constructing a portfolio which is having the highest return with the minimum risk. So at the end of in the discussion, we need to calculate the portfolio return. So we will be given risk-free rate of return, there is a treasury bill return. We will be given market variance, that is the Sensex variance or Nifty variance. Then we will be given, say, 7 stocks or 8 stocks we will be given, and we will be given the return of these 7 stocks or 8 stocks. Then we will be given beta of all these stocks, and we will be given unsystematic risk of all these stocks. So these are all the information given. So for the project, so when we go for a project of constructing an optimal portfolio, these are all the calculation that we need to have. So when you go for because this is a project, it's a very big project. So for example, when we go for a 4th trimester project, so this construction of portfolio by using single index model is a project. So you can take this one as a project, and then you can move forward. So here we are taking only 8 stocks, but when you go for a project, you need to take 50 stocks. So for example, Nifty, from the Nifty 50 stocks we need to take, and from that 50 stocks, so how do we construct an optimal portfolio? So that is your project. Or from 30 stocks, how do we construct an optimal portfolio? That is your project. So here, the same methodology is same. Methodology would remain same. So here you are taking only 8 stocks because the time constraint. We cannot complete for an examination by taking 30 stocks or 50 stocks. So for examination point of view, for the discussion point of view, we can take only 8 stocks, but 10 stocks. But when we go for a project, the same methodology that you have to apply for 50 stocks or 30 stocks, by which you are saying, so these are all optimal portfolio, that is your findings, that is your interpretation. So this is the complete project that you can take up. So here, for a project when we go, you can take a treasury bills return from the RBI website. I have shown you the RBI website, how we can take the treasury bills return. The left hand side, the RBI website, it is given either 182-day treasury bills or 91-day treasury bills return you can take. So you can take 182 days treasury bills rate you can take. Then you need to calculate the market variance. But here in our discussion today, market variance will be given the case. But for the project point of view, you will have to calculate the market variance. So we know what is the market variance. So market return you need to calculate. That is the closing stock return, closing index minus opening index divided by opening index will give you the market return. Then get the average of the market return minus then actual market return minus the average return, square it, then take the root of square it, divide by n minus 1 will give you the standard deviation, will give you the variance. Then you need to calculate every stock beta. So stock beta, you can take it from moneycontrol.com. It is there. Moneycontrol.com, it is there. But that beta you cannot take away because that beta will be relevant for a particular time period. So you may be taking for 5 years or you may be taking for 3 years. So that particular beta you may not know. So you need to calculate every stock beta. So you are taking say Sensex. So Sensex, all the Sensex beta you need to calculate. Then you need to calculate the stock return. Stock return for all the 3 years. Average stock returns we need to calculate. That is the closing stock return minus opening stock return divided by opening stock return will give you the stock return, and take the average of 3 years or 5 years you can take. That will give you the average return. Then you need to calculate the unsystematic risk. That is the standard deviation that you need to calculate. So these are all the calculations that you need to make for constructing the optimal portfolio. So it is for your project point of view. But in our case, all this information will be given. So we need to compute the optimal portfolio. So please take step 1. Step 1, compute risk-reward ratio. So we need to compute first risk-reward ratio. Risk-reward ratio. We call it RRR. Triple R. Risk-reward ratio. That's the first step. We need to calculate risk-reward ratio. What is called? It is an investor assuming very high risk. So when the investor is assuming very high risk by investing his money in the stock, the market, he has to be given an extra reward. So you take low risk, you assume low risk, you will be given low return. When you assume higher risk, you should be given higher return. So that is called reward. That is called reward. So that is what we call it as a premium. We have seen earlier MRP, market risk premium. We have seen in SML, a securities market line. That is RM minus RF. That is called, we call it market risk premium. Okay. So what is the reward that is getting? The reward is RI minus RF. What is RI? The return of a particular stock. The return of a particular stock is a RI. What is RF? The risk-free rate. Risk-free rate of return. Okay. That is the treasury bill return. So this is what the reward. The reward is an investor is assuming an extraordinary risk. So for that, he is given the reward. So what is the reward? The return of a stock minus risk-free return. That is called the reward. Here we are going to calculate risk-reward ratio. So what kind of risk an investor cannot eliminate? An investor cannot eliminate market risk. An investor cannot eliminate systematic risk. So the systematic risk is measured through beta. So divide it by beta. Beta of the stock. So that will give you risk-reward ratio. The risk-reward ratio is a difference between risk-free rate of return, return of a stock and risk-free rate of return, and divide it by the risk. What risk? Systematic risk. Because here we cannot divide it by total risk. Why? Because risk means, as I was mentioning earlier, risk means only market risk. The total risk is a combination of market risk and unsystematic risk. Systematic risk and unsystematic risk. But unsystematic risk can be eliminated. So unsystematic risk can be mitigated. It can be reduced. So here risk means systematic risk. Systematic risk is measured through beta, so divided by beta. So that will give you risk reward ratio. Okay, the first step. Second step, so you are given 8 stocks or you are given say 7 stocks. So you are given say 5 stocks. Rank all the stocks based on risk reward ratio from the highest to the lowest. Second step, please note down. First step is compute risk reward ratio. Write the equation Ra minus Rf divided by beta I. Second, rank all the stocks in a portfolio, the given portfolio, based on risk reward ratio from the highest to the lowest. So rank the stocks based on RRR, triple R, based on triple R from the highest to the lowest. From the highest to the lowest. Okay. Then, now, third step is, please note down, third step, hope all of you have written the first two steps. So first step is compute the risk reward ratio, write the equation. The equation is Ra minus Rf divided by beta I. Then second is rank all the stocks based on triple R from the highest to the lowest. Now, here what we are going to do, we are given 8 stocks or we are given say 9 stocks. Okay? And we are taking not all the 8 stocks. So we are going to, from these 8 stocks, what are the stocks going to be part of the optimal portfolio? That is our discussion today. That is our work today. So from 8 stocks, some stocks will be part of portfolio, some stocks will not be part of portfolio. So we need to get what is that criteria on which some stocks will be part of the portfolio, some stocks will be not part of the portfolio. How we can eliminate those stocks. So that point is called cutoff point. So third step is compute. Third step is compute the cutoff point. Okay. The cutoff point here means at what level of, what point those stocks will be part of the portfolio and some stocks will not be part of the portfolio. So that point is called the cutoff point, single cutoff point. So that single cutoff point we need to calculate. So kindly write, compute the single cutoff point. Single cutoff point. That is a particular cutoff point that we need to calculate. Now, please don't write, I'm not telling you the equation now. So if you write the equation now, you may not understand. So when we go for a case study, we will write the equation. So kindly give the space for writing the equation. We can write the equation later on. So kindly give the space now. We can write the equation later. After complete the case study, we'll come back here and we'll write the equation. Okay, so third step is compute a single cutoff point. Now, fourth step is, kindly write the fourth step. Now we need to eliminate certain stocks which don't fall into this particular optimal portfolio. So how do we eliminate that? If the risk reward ratio is greater than single cutoff point, such stocks will be part of optimal portfolio. If the risk reward ratio is greater than single cutoff point, such stocks will be part of optimal portfolio. If the risk reward ratio is less than the cutoff point, single cutoff point, such stocks will be eliminated from the single cutoff, eliminated from optimal portfolio. Okay, so this is how a portfolio manager constructs the fund mutual fund. So that's why you need to understand it's a mutual fund is like a pilot. Because pilot is a person who controls the entire aircraft. The same way, the entire mutual fund performance is being determined by the individual conceptual knowledge of a particular portfolio manager or fund manager. So if the fund manager leaves the company, certainly that particular fund value will fall down. That we need to keep in mind, because the mutual fund performance purely depends on the fund manager capability, fund manager competence, fund manager market knowledge, market competence. That we need to understand. Okay? So he constructs the mutual fund based on all these constraints. So please write the fourth step. Fourth step is if the risk reward ratio, if the risk reward ratio is greater than single cutoff point, such stocks will be selected. Such stocks will be selected or will be selected for optimal portfolio. If the risk reward ratio is less than cutoff point, such stocks will not be part of the optimal portfolio. If risk reward ratio is less than single cutoff point, I have written SCP, single cutoff point, less than single cutoff point, such stocks will be removed. This is the fourth point. Now we need to calculate. So you have constructed a portfolio now. So you have from 8 stocks, say only you are taking only 3 stocks. The remaining 5 stocks is not fulfilling this particular criteria. So you are removing those 5 stocks. So you have only 3 stocks. Now, our question here is, if an investor has got say 10 lakhs and investor has got say 50 lakhs. Okay. So for example, if Sachin has got 2 portfolio managers to construct his fund, to construct his portfolio. He has got 2 fund managers. So HNIs, high net worth individuals, they have a huge amount of money. So our question here is, you have 20 lakhs or 30 lakhs we have. So how do we distribute, how do we allocate these 20 lakhs or 30 lakhs among these 3 stocks? So from 8 stocks, you are taking only 3 stocks. 5 stocks eliminated. So how do we contribute? How do we allocate the funds? So for example, is it equal? So 33%, or you want to have 50%, 25%. So what is the allocation of funds? So that we need to calculate. Okay, so that we can calculate the portfolio return. So what is the portfolio return? Multiply the weights with the return. Already we know the return now. Stock return is given already in the case. So weights we need to calculate. So what is called weight? What is a proportion of funds that need to be allocated? So that's the next calculation. That is the calculation of weights. How to calculate the weights? Okay. A proportion of funds to be invested. So heading, proportion of funds to be invested. Proportion of funds to be invested. How do we calculate? That is the weights that we are going to calculate the weights. That is beta I divided by USR. USR is nothing but unsystematic risk. USR, unsystematic risk. Okay. Into triple R minus SCP, single cutoff. I repeat, after computing what are the stocks will be part of the optimal portfolio, we need to find out at what proportion, at what percentage of funds that need to be invested in each stock, which is being part of optimal portfolio. So that's what we call the proportion of funds to be invested, or we call it weights. How do we get the weights? So we need to, beta is given, beta I, divide by unsystematic risk, that is given the case, multiply with triple R minus SCP, that is single cutoff point. Single cutoff point. We can get the proportion of fund invested. So now you are given weights. Weights you have, WI we have, and we have return is given already in the case. So multiply both. That will give you the optimal portfolio return. So last step is computation of optimal portfolio return. Computation of optimal portfolio return, that is WI into R. Multiply W with RI, that will give you optimal portfolio return. I repeat all the steps. Those who have not written, kindly note down, because very, very important, not only for the examination point of view, not only for because the main objective of this particular course is this. After this is the last part of a discussion. How an investor can construct a portfolio which is optimal. Anybody can construct a portfolio. You take up 2 stocks or 3 stocks, you can construct a portfolio. That is not the portfolio. Portfolio must be optimal. So what is called optimal? For a given level of risk, the return is maximum. For a given level of return, the risk is minimum. So that's called optimal, or that's what we call it efficient portfolio. That is the construction of the portfolio. That's the last part of our discussion. So first, we will be given risk-free rate of return. We will be given market variance. We will be given, say, 8 stocks or 10 stocks. Return will be given, beta will be given, and unsystematic risk will be given. First, we need to calculate risk-reward ratio. That is what we call it, triple R, risk-reward ratio. How do we get that? Ri minus Rf divided by beta I. Why are we dividing it by beta I? Because beta measures systematic risk, which is known as the total risk. Though the total risk is a combination of systematic risk and systematic risk, unsystematic risk can be mitigated. Unsystematic risk can be eliminated. So here risk means systematic risk. So that's why we are dividing it by beta. Then rank all the stocks from the highest to the lowest, so that we can come to know what kind of stocks can be eliminated, what kind of stocks will be part of the optimal portfolio. Then third step is we need to compute the single cutoff point. That particular point, we are eliminating some stocks. Some stocks will be part of the optimal portfolio. Then we need to have fourth step is we need to compare the risk-reward ratio with the single cutoff point. If the risk-reward ratio is greater than single cutoff point, such stocks will be part of optimal portfolio. The remaining stocks will be rejected. Then we need to compute the proportion of funds. What percentage of funds that we need to be allocated among all the optimal portfolio stocks. So how do we get that? Beta divide by unsystematic risk, multiply with risk-reward ratio minus the single cutoff point. That will give you the optimal portfolio return. Case study is there. Mr. Vishal received 2 million from his pension fund. He has got 20 lakhs from his pension fund. He wants to invest in the stock market. The treasury bill rate is 5%. As all of us know, that is called the risk-free rate of return, 5%. Sensex return variance is 10%. That is the market variance. Market variance is 10%. The following table gives the details regarding the expected return, beta, and residual variance. Residual variance is nothing but unsystematic risk of the individual security. Construct the optimal portfolio and determine the optimal portfolio return. So what we are given? So we are given 7 stocks. We are given 7 stocks return. We are given 7 stocks beta, and we are given 7 stocks residual variance, or we call it unsystematic risk. We are given. Okay. So from this we need to compute the optimal portfolio return. So first step, we need to calculate the risk-reward ratio. First you get the risk-reward ratio of all the stocks. Okay. So first step, risk-reward ratio. That is Step 1, triple R we need to calculate risk reward ratio. That is Ri minus Rf divided by beta I. Okay. So stock 1. What is stock 1? Please take the calculator. Keep it ready with the calculator because a lot of calculation is there. So please take the calculator. 19 minus 5 divided by beta is what? 1. Beta is 1. So 14. Second stock, what is Ri? Second stock Ri is 23. So 23 minus 5. 5 is the risk-free rate of return. It is given in the case. Divide by beta. Beta of the stock. Beta of the stock is 1.5. So 23 minus 5 divided by 1.5. So 18 divided by 1.5. Which comes? Yes? 12. Third stock is 11. 11 minus 5. 11 minus 5 divided by 0.5. That is 12, no? 12. Then fourth stock. Fourth one is 25 minus 5 divided by 2. That is 20, 10. 10. Fifth stock is 13 minus 5 divided by, what's the beta? Beta is 1. Beta is 1. So 8. Sixth stock number 6. Stock number 6 is 9 minus 5 divided by 0.5. 0.5. So 4, 2, correct? Is it 2, no?
8, sir.
Sorry, 8. Yeah, sorry. 8. Yeah, 8. So 7th stock. 14 minus 5 divided by 1.5. 1.5.
6.
6. Okay. 6. So, any clarification? First step? Any clarification regarding first step? Risk reward ratio? Risk reward ratio. Any clarification? Anybody? Risk reward ratio, any clarification? Okay. Now, second step is arrange the stocks based on triple R from the highest to lowest. From the highest to lowest, we need to arrange the arrange the stocks. So here, incidentally, all the stocks are arranged. So 14, 12, 12, 10, 8, 8, 6. So it is arranged based on that. So same order you can follow. You can follow the same order because the order has come from the highest to lowest only. The same order you can follow. So the second step is already, you need not write second step because second step is there already. Then go to the third step. So third step is computation of single cutoff point. So kindly listen. So I am single cutoff point. Third step is single cutoff point. Okay. That is single cutoff point, SCP. Third step is SCP. Right? All the stocks from the highest to lowest. So when you take from the highest to lowest, that is stock, Ri. That is, then next we have beta I. Then this unsystematic risk, it can be denoted like this: standard deviation square EI. Okay, standard deviation square EI is called unsystematic risk. That is the symbol. Okay, so standard deviation square EI is called unsystematic risk. Okay, so we have stock 1, 2, 3, 4, 5, 6, 7. Because it's already arranged the highest to lowest only. Okay, so we need to arrange for the highest to lowest. So then triple R. Okay. So Ri is how much? So please tell me the Ri. 19, 23, 11, 25, 13, 9, 14. Okay. Beta is 1, 1.5, 0.5, 2, 1, 0.5, 1.5. Then standard deviation square I, that's called unsystematic risk. That is 20, 30, 10, 40, 20, 15, 30. 50. Okay. 50. Okay. So 50, 30. Okay. Triple R we calculated from the highest to lowest. We need to arrange highest to lowest, but here stock 1 to stock 7, the same order is followed. So we need not change the stocks. So triple R, stock 1, 1, 4, 14, 12, 10, 8, 6. Okay. Now we need to get a single cutoff point. To get a single cutoff point, the first step is to get a single cutoff point. First step, Ri minus Rf minus Rf into beta I divide by standard deviation square Ei. Okay. Ri minus Rf into beta I divide by standard deviation square I, that is unsystematic risk. So how do we get that? That is 19 minus 5 into 1 divided by 20. 19 minus 5, that is 14, into 1, that is 14, divided by 20. 14 divided by 20. How much comes?
0.7.
How much? 0.7. Got it? All of you got it? So how do we get that? This is the first step in single cutoff point. So single cutoff point has got sub-steps. Single cutoff point calculation has got a sub-steps. Step 1, Ri minus Rf into beta divided by unsystematic risk. That is 19 minus 5 into 1 divided by 20. Now next, 23 minus 5 into 1.5 divided by 30. 0.9. Then 11 minus 5 into 0.5 divided by 10. 0.3. 25 minus 5 into 2 divided by 40. 1. 13 minus 5. 13 minus 5 into 1 divided by 20. 0.4. Then 9 minus 5 into 0.5 divided by 50. 0.04. Then 14 minus 5 into 1.5 divided by 30. 0.45. Is that clear, all of you?
Yes.
Okay. Now next is second sub-step. The second sub-step is beta square the beta divide by standard deviation square Ei. That is, you need not the square because unsystematic risk itself is a standard deviation square, so you need not square it. So beta square divided by unsystematic risk. Beta square divided by unsystematic risk. That is 1 square divided by 20. 1 square divided by 20.
0.05.
Huh?
0.0.
0.05. Then second, 1.5 square. 1.5 square divided by 12. 1.5 square divided by 12.
0.1875.
0.1875. So kindly take all the decimals.
So divided by 30, no, sir?
Divide by 30. Yes. 1.5 square divided by 30.
0.075.
0.075.
75. Okay. 0.075. Okay. Take all the decimals. 1.5 square divided by 30. Then 0.5 square divided by 10.
0.025.
0.025.
0.025. Then 2 square divided by 40.
0.1.
0.1.
0.1. 1 square divided by 20.
0.05.
0.05.
0.05.
0.05. 0.5 square divided by 50.
0.005.
0.005. 1.5 square divided by 30.
0.07.
0.075. Okay. This is the second step in single cutoff point. Then third single step. Third substep. Take the cumulative of the first value, that is Ri minus Rf into beta I divided by standard deviation E square. Then take the cumulative of beta square divided by unsystematic risk. So take the cumulative of the first one. Cumulative of the first substep, that is 0.7. Cumulative of Ri minus Rf into beta I divided by standard deviation square EI. That is 0.7 cumulative. 0.7 plus 0.7 plus 0.9, 0.16, 0.16 plus 0.3. So take the cumulative.
1.9.
0.19, 0.7 plus 0.016.
1.6. Second one.
1.6, correct. 1.6,
1.9.
1.9,
2.9.
2.9,
3.3.
3.3,
3.34.
3.34,
3.79.
3.79.
79.
All of you got it? There's a cumulative. Cumulative of the substep 1. Then cumulative of substep 2. That is sigma beta square divided by standard deviation square EI. That is 0.05, 0.05, 0.05 plus 0.075, 0.05 plus 0.075,
0.125.
0.125,
0.15.
0.15,
0.25.
0.25,
0.3.
0.3,
0.305.
0.3055.
No. One more is
100.
I have one more is
Yeah.
that is 0.3. Last one.
Yeah, 0.05. Yeah. Point. Third one is how much?
Yeah. 1.5. 0.15.
0.15.
Fourth one, that next one. The same.
Yeah. That is
2.5.
0.25.
2.5. Yeah, the same one. 0.3.
0.3.
Then
0.305.
next 0.38.
0.38.
3.
Okay. Okay. Now,
Sir, I got it.
which one?
So the fourth one is 1.15.
Now, first one is 0.05.
Yes.
Second one is 0.125.
Yes, sir.
Third one is 0.15.
Yes, sir.
Fourth one is 0.25.
1.15.
That is 0.15 plus 0.1.
Okay, sir.
Correct now?
Yes.
0.15 plus 0.1, 0.25.
Yes, yes, it is correct.
Correct. 0.3, 0.305, 0.38. Okay. Now we are coming to the fourth substep in single cutoff point. Okay. I write the column number here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Now single cutoff point. So single cutoff point, we are getting that SCP, single cutoff point, is, please listen, market variance into 8th column. Market variance into 8th column. Market variance into 8th column divided by 1 plus market variance into 9th column. How do you get? Market variance into 8th column divided by 1 plus market variance into 9th column. So market variance is given. Sensex variance is given. That is 10%. So 10 into 0.7. 10 into 0.7 divided by 1 plus 10 into 0.05. Got it? I repeat. 10 into 8th column. 8th column is 0.7. So 10 into 0.7 divided by 1 plus 10. 10 is market variance into 9th column. 9th column is 0.05. How much? So how is the equation? Market variance into 8th column divided by 1 plus market variance into 9th column. That is 1.
12.7.
Huh?
12.7 to 12.4.
Got it? Is that right? That is 10 into
0.7
0.7 divided by 1 plus 10 into 0.5.
So in the
0.05.
in the denominator, how 1 plus 10. So
1 plus 10. So first you multiply this, then you add. Check once again. I repeat. So 10 into 0.05. 10 into 0.7 whole divided by 1 plus 10 into 0.05. So 10 into 0.7 how much? 10 into 0.7?
so how many
7. So 7 divided by 1 plus 10 into 0.05.
0.55.
0.55. So 7 divided by 1.55. 7 divided by 1.55. How much comes?
So no. So
What?
you have to multiply and then add.
Oh yeah.
10 into 0.5.
Yeah. You not add and multiply, no?
10
1.
into 0.5.
1 point, yeah. 10 into 0.05 is
0.5.
0.55. 1.55.
1.5.
Yeah. 55. So 7 divided by 1.5. Yeah, 7 divided by 1.55. How much?
4.67.
4.67. Got it? All of you got it? Any clarification? Anybody? Because it's a board mass formula, so you cannot add first, then you cannot multiply. You should multiply first, then you can add. So in board mass, first you multiply, then only addition. Okay, so first you multiply, there is 10 into 0.05, then you add.
there is one mistake. 10 into 0.5 is equal to 0.5, not 0.55. 1 plus 0.55. No.
10 into 0.05.
Is equal to 0.5 only, not 0.55.
10 into 0.05, how much comes? Hello?
0.55.
10 into 0.05.
0.5, sir.
0.5. Yeah, 10 into 0.05 is 0.5. So 1.5. 7 divided by 1.5. So 7 divided by 1.5, how much?
How many decimal points?
0.67.
4.67.
How many decimal points?
3 decimals you can take.
667.
4.67. Yeah, correct. 4.67. So 4.67. The first one is 4.67. First one is 4.67. Okay. First one is 4.67. Second one.
7.11.
Second one, how much comes?
7.11.
7.11. Third one.
7.6.
7.6. Fourth one.
8.29.
8.29. Fifth one.
8.25.
8.25. Sixth one.
8.25.
8.25. Seventh one.
7.9.
7.9. Please listen. Please listen. So all this calculation, if you are in Excel sheet, if you are having Excel sheet, spreadsheet, easily you will get the answer. But spreadsheet will not give you at what is your single cutoff point and how you select the optimal portfolio. So that is what our human wisdom is required. That is what we require, the subject knowledge that the system doesn't know. So you compare, look at the pattern. Look at the pattern of single cutoff point. This is what we call it cutoff point. Don't write cutoff point. It's not a single cutoff point. Cutoff point. Cutoff point. Okay. So look at the point. First one is 4.67. Second one is 7.11. Third one is 7.6. Then 8.29. Then 8.25. 8.25. 7.9. What's the pattern? Anybody? What is the pattern which is followed? What's the pattern? It is increasing up to a certain point of time, then it starts decreasing. Cutoff point starts increasing up to a certain point, then after that point, it starts decreasing. So it starts increasing up to here, 4.67, 7.11, 7.6, 8.29, after which it starts decreasing. So this is what the single cutoff point, 8.29, the point at which it starts decreasing. So that point is called single cutoff point. So single cutoff point is a place where it starts increasing up to a certain point, then it starts decreasing. That is called single cutoff point. Okay, so compare the single cutoff point with the risk reward ratio. Okay, so risk reward ratio, the first stock is 14. The single cutoff point is 8.29. So stock 1 risk reward ratio is greater than single cutoff point. So stock 1 will be part of optimal portfolio. 14 is risk reward ratio is 14. Single cutoff point is 8.29. So risk reward ratio is greater than single cutoff point. So that particular stock will be part of optimal portfolio. Second stock, risk reward ratio is 12, 8.29. So second stock risk reward ratio is greater. So that will be part of optimal portfolio. Third stock is 12, 8.29, which is greater. That will be part of single cutoff point. 10, 8.29 is greater. That will be part of single cutoff point. Look at the fifth stock. Fifth stock is risk reward ratio is 8. Single cutoff point is 8.29, which is less than single cutoff point. That will not be part of optimal portfolio. That will be removed from the portfolio. So 5, 6, 7 will not be part of optimal portfolio. So optimal portfolio can be constructed only when The single cutoff point follows that certain pattern. Please understand. See, for example, here it is 4 point. For example, here is 5. Then it is 7. Then you have a 4.5. Then you have a 6. It is 7. Then it's 8.5. If it is fluctuating, the cutoff point is fluctuating. For that particular stocks, we cannot construct optimal portfolio. So your answer ends there. Okay, so you can construct optimal portfolio only when the cutoff point has got certain pattern. So what is a pattern? It starts increasing up to a certain level, then it starts declining. So that particular point, the highest level of the cutoff point is called single cutoff. It starts increasing up to certain level, up to certain point. After that, starts declining. The cutoff point starts declining. Okay, so that point is called single cutoff point. If the cutoff point does not follow the same pattern, then you cannot construct the optimal portfolio. You can write the optimal portfolio cannot be constructed by using the given information. With that, your answer ends. Okay. So fourth step. What are stocks? So what are stocks are part of optimal portfolio? Stock 1, stock 2, stock 3, stock 4. So please write. Before you write, please write the equation. What we wrote? You are given the space. So please write the equation for cutoff point. Please write the equation for cutoff point. I write the equation here. Please write the equation. That is cutoff point. Cutoff point is equal to. So how do we write? Market variance. Market variance into, write the equation. Sigma Ri, 8th column you write. Ri minus Rf into beta I divided by saturation square EI, 4 divided by 1 plus market variance into saturation beta square beta I square divided by saturation square EI. This is called single cutoff point. So when you write, so now you understand, you can write it. So market variance, please write the equation given. Please write it. When the previous point you didn't write the equation, please write it. Market variance into sigma Ri minus Rf into beta I divided by saturation square EI. That is the 8th column. Please write the 8th column. Whole divided by 1 plus market variance into 9th column. 9th column is sigma saturation sigma beta square divided by saturation square EI.
Yes.
Yeah. So now we have 4 stocks are selected. So we need to get the proportion of funds to be invested. So we need to get that proportion of funds to be invested. Okay. So we have taken 4 stocks now. So out of 4 stocks, how these 20 lakhs have to be invested? Because the person has got 20 lakhs now. He has got 20 lakhs. So how we can allocate these 20 lakhs among these 4 stocks? Is it equal? It is 25%, or it is on what percentage he has to invest his funds? So that we need to get that. So step 5 is proportion of funds to be invested. Proportion of funds. Step 5. Proportion of funds invested. That's what called weights. We are going to calculate the weights. Okay. How do we get that? Beta I divided by saturation square EI, that is unsystematic risk. Triple R minus single cutoff point, AC. Okay. So stock 1. What is the beta? Stock 1 is, beta is how much? Beta is, anybody? Stock 1 beta? Beta is 1. So 1 divided by standard deviation square I, that is 20. 1 divided by 20. What is triple R? Triple R is triple R for stock 1? 14. So 14 minus 8.29, single cutoff point. 1 divided by 20. 14 minus 8.29. How much comes? How much comes? 0.2855. Second stock, that is, second stock is 1.5 divided by 30. 1.5 divided by 30 whole divided by, what is triple R? 12 minus 8.29. Third stock, 0.1855. Third stock beta is 0.5 divided by 10. 0.5 divided by 10 whole divided by 12 minus 8.29.
Same. 0.1855.
0.1855. Same answer we get.
Yes.
2 divided by unsystematic risk is 2 divided by 40. 40. What's the risk reward ratio?
10.
10 minus 8.29. 0.0855. That's what, see, please listen. The risk reward ratio, that's what I said, risk reward ratio is greater than single cutoff point. So when you do it here, risk reward ratio minus single cutoff point, you should not get minus here. You should not get minus, you should be always positive. That's why we are taking the risk reward ratio which is greater than single cutoff point. Then only you will get positive, otherwise you will get negative. So we should never get negative here. So now add this. So this value you can take it as Z. This value is called Z. Okay? Z is equal to, Z means the weights. Z you can calculate. So calculate sigma Z. Sigma Z.
0.74.
Sigma Z
0.74.
0.74?
0.742.
742. Add this. Okay? Then you calculate the weights. That is W. WI. That is 0.2855 divided by 0.742. So please listen, this is not the weights. What we have calculated is not a weights. What we calculate is a proportion. Proportion are calculated. So add the proportion, total it, and divide it by each one. That is 0.2855 divided by 0.742.
So how many decimal points?
2 decimals you can take. So 0.2855 divided by 0.742.
0.38.
0.38. That is 38%. So 38% of funds will be invested in stock 1. 38% of funds. So 38% of funds will be invested in stock 1. 0.1855 divided by 0.742. 0.25. That is 25% of funds. That is 25% of 20 lakhs. 25% of 20 lakhs is 5 lakhs. So 5 lakhs he has to invest in stock 2. 5 lakhs. Then 0.25, again 0.25, that is 25%. So under 5 lakhs he has to invest in stock 3. 0.12, that is 12% he has to invest in. Total is 100%. 100%. Okay, this is step 5. What proportion he has to invest in his funds. Okay, so out of 50% of funds, 38% of funds he has to invest in stock 1, 12% of funds he has to invest in stock 2, 25% each he has to invest in stock 2 and stock 3 out of 20 lakhs. Now we have to get the portfolio return. So portfolio return is compute compute the, step 6. Step 6 is multiply with portfolio return, optimal portfolio return. Optimal portfolio return. Optimal portfolio return is WI into R. That is 0.38 into what is stock return 1? 19 plus 0.25 into return is given. Return is given the case 0.25 into 23% plus 0.25 into 11. 0.25 into 11 plus 0.12 into how much? 25. So you will get the total return, optimal portfolio return. Optimal portfolio return. How much you get? $18.69. 18.69 is your optimal portfolio return. So if we invest in these stocks, so his total return will be 18.69. Next one more case. The second one is the same. You can do it by yourself. Second one. Look at the third case. Please look at the third case. What is given here? Mr. David is constructing an optimal portfolio. The market forecast says that it would be 13.5 for the next 2 years with the market variance of 10%. So market return is 13.5. Okay. The risk-free rate of return is 5%. The following securities are under review. Construct optimal portfolio. Okay. Now here there are 5 stocks given. What is given is alpha is given. We are not given the return. We are given the alpha. So how do we get the return of a stock when the alpha is given? Anybody? Any clue? We have seen all this. Any clue on that? So we have calculated a regression line, correct? We have calculated the regression line. So as per the regression line, so how do we fit the regression line? Alpha plus beta into RM. That is R, regression line. So when we have a regression line, that is Ri is equal to alpha plus beta I into Rm, that we have seen earlier for fitting the regression line. For fitting the regression line, we have seen that. Okay. So now Ri, how do we get? Alpha is given. We are given beta and we are given market return. Market return is given. Earlier 13.5 market return for next 2 years. It is given there. So how do we get the return? That is first one. Anil, first stock A. Anil is a stock. So what is alpha? Alpha is 3.72. 3.72 plus beta is 0.99. 0.99 into 13.5. That will give you the market stock return. Okay, so that will give you the stock return. So this regression line we have seen earlier. So you have in the assignment also you have calculated the regression line. Okay, the same thing. That is, so what's the return? What's the return? How much is coming? How much is coming? 0.6. Next one, 0.60 plus what is beta? Beta is given Beta is 1.27. 1.27 into market return. Market return is 13.5. That is given. So how do you get that? So what is the first one? What is the first answer? Next one is bow. 19 point? 17 point? 17.085. Second one is how much comes? Third one is bow. Bow is how much? That is 0.41. 0.41 plus beta is how much? Beta is 0.96. 0.96 into 13.5. Fourth one is viral. That is viral. Minus 0.22 plus what's beta? Beta is 1.21. 1.21 into 13.5. The next one is we have Billy. That is 0.45. 0.45 plus what's the beta? Beta is 0.75. 0.75 into 13.5. So how much comes? Second stock how much? Anybody? Second stock return how much? Second stock return how much? Anybody? How much comes for second stock?
23.
Second stock is 23. Second stock 23. Third one 11. Second one is how much? 17.745. Okay. 17.745. Third one? Third one how much?
13.37.
13.37. Fourth one? Fourth one? 16.115. Fifth one? Fifth one?
10.575.
10.575. Okay. Yeah. So so if the R is not given, you will be given the alpha. You can calculate the R by the given information. So in that case, market return will be given. Market return will be given, so you can calculate the return of the particular stock. Now the we need to calculate. First, we need to calculate the risk-reward ratio. Then calculate, arrange the stocks in the highest to lowest. Get the cutoff rate. Get the single cutoff rate. Compare. Get the optimal portfolio and get the Z value. Get the weights and multiply with the weights with the return. That will give you. Shall we do it?
Yes, sir.
Okay, we'll do it. Risk-reward ratio. Calculate risk-reward ratio. Triple R. Calculate triple R. Risk-reward ratio, that is triple R. Triple R is, that is Ri minus Rf divided by beta I. So stock one is how much? Anil?
17.085.
So that is Ri is how much? 17.085
085.
minus Rf is 5 divided by beta how much?
0.99.
0.99. 0.99. How much comes? Anil?
How many decimal points are?
3 decimals you can take. 3 decimals you can take. Abil? What is the stock? What is the return?
17.745.
17.745 minus 5 divided by
1.27.
1.27. First one how much?
12.207.
12.207.
207.
Third one?
Second one 10.035.
10.035.
35.
Third one is
Answer of
third one is bow.
13.37.
Bow. Bow is what's the return?
13.37.
13.37 minus 5 divided by
0.96.
0.96.
Answer is 8.719.
8.719. Then Viral. That is
16.115.
16.115 minus 5
divided by 1.21.
1.21.
9.186.
9.186
Billy.
Yeah. Billy. That is Billy is
10.575.
10.575
minus 5.
minus 5 divided by
0.75.
0.75.
7.433.
7.433.
433.
So arrange the stocks. Second step, arrange the stocks from the highest to lowest. So this is the first rank. Second, this will be third. This will be fourth. This will be fifth. These are rank. The highest to lowest. Okay. Now get the cutoff rate. Cutoff rate. So when you arrange it, you should arrange in this order. So when you go to the second, third table, you need to arrange it in this column, in this order. That is, first one is first stock Anil, second one is Avil, third one is Viral, then Bow and Billy. So like that you need to arrange.